Okay, 6-6 is the last section we're going to be covering. I split it into 2 days, so this is the first part of 6-6. I will be able to find instantaneous rate of changes by calculating slope of tangent lines. So when we approximate slopes using secant lines, basically, if we're trying to find the slope, the instantaneous slope at y equals x squared, that's what this graph is, at 1, 1. We're trying to find the slope at that specific point. We're going to draw secant lines, or lines secant to this. And we can draw kind of approximate secant lines at different positions and then figure out which one is the best approximation. So we can make it steeper or less steep until we find the perfect line that's going to graph those points and give the instantaneous rate of change. So basically, we are going to be using calculations to find that perfect slope. So the tangent line is the line that best approximates the curve at that point. The slope of the line represents the rate of change at that instant. So to define the slope of a tangent line to y equals f of x at the point x, f of x, because that's our coordinate. Find the slope of the secant line through this point and one other point on the curve. Let the x-coordinate of the second point be x plus h for some small value of h. The corresponding y-coordinate would therefore be f of x plus h. So we have our original point, x and f of x, and then we're going to add h, so go up by h to each, and that's our new point. So if we want to find the slope of a point, remember it's change in y over change in x. So we're going to do the difference of this term. Sorry, the difference of the y terms over the difference of the x terms. And you see that here. So the difference f of x of h minus f of x divided by the x plus h minus the x. And then if you simplify, the two x's on the bottom cancel. So this is our formula. So that is the formula we're going to be using to find the instantaneous rate of change on the problems. There are going to be 2 examples we're going to do, and then you'll do 4 on your own. Or if you come to my live session at noon, to the session at noon, we can do them together. So if you're not sure how to do the worksheet on your own, come at noon and we can do them together. So example 1, find the slope of the line at tangent to the graph at yx squared at 1, 1. So that's at this point. So what we're going to do to solve this is we're going to take our formula that we just talked about. M equals the limit of x as it approaches 0 of f of x plus h minus f of x over h. And then we're going to plug in our x value, which is 1. So f of 1 plus h minus f of 1 over h. Sorry for all the shadowing. And then we're going to go plug in our function. So the function is x squared. So replace the functions with the actual function. So 1 plus h is x squared minus, and then here it's 1 is x squared over h. And then to simplify that, we're going to do, I'm going to go this way. 1 plus h squared is 1 plus h times 1 plus h minus 1 squared is 1 over h. If I distribute this out, I get 1 plus 2h plus h squared minus 1 over h. The 1's cancel, so I have 2h plus h squared over h, which then gives me 2 plus h. So I've simplified down to here, and now we're doing the limit as x approaches 0, so we can use substitution. 2 plus 0 equals 2, so the answer is m equals 2. Sorry for going around in circles. So now from this point, if we go up 2 and over 1, that is the line that is represent the instantaneous rate of change. Okay, so we're going to use the formula. We're going to plug in the x value. Then we're going to plug in the entire value into our function, whatever it is, and simplify. Once we're simplified, we're going to replace the h with 0. This should be h as h approaches 0, sorry. Okay, so that's why we plug in the 0 for h. So let's look at the second one. The expression for instantaneous rate of change can also be used to find an equation for the slope of the tangent line of graph at any point. So find the equation for the slope of the graph m at any point. So if we look at this function here, and you see the curved lines, that's our function at y equals 4 over x. see how the slope is going to change depending on what point you're at? So we need a generic formula that will work for any point. So the formula limit as h approaches 0, and then we have f of x plus h minus f of x over h. And now we're going to plug in, since we're doing any point, we're just going to go directly and substitute these in. So we're going to put 4 over, this whole thing is x, so x plus h minus, and then this is going to replace x, so 4 over x, divided by h. Now in order to simplify this, we need a common denominator to simplify our numerator. So our common denominator is going to be x times x plus h. Okay, and then the whole thing is still over h. So on this one, we multiplied by x on the bottom, so we put an x on the top. On this one, we multiplied by x plus h. So now we're going to work on simplifying this. So on the top, we have 4x, and then we're going to take the negative 4 and distribute it, so minus 4x, and then minus 4h over x times x plus h, and that whole thing is over h. So simplifying further, the 4x's cancel, so we have negative 4h over x times x plus h, and that's being divided by h. So then that's going to give me negative 4h, x times x plus h. When you divide, you change it to multiplication and you do the reciprocal. So the reciprocal of h is 1 over h. And now these h's will cancel. So I have negative 4 over x times x plus h. And the rule was, h approaching 0. So we're going to substitute in the 0. Negative 4 x times x plus 0, which would give me negative 4 over x squared. So m equals negative 4 over x squared. That is at any point. So if we go back and check this on our graph, I'm going to write it next to the graph. And we go to, say, this coordinate here, and we use this point here, and we're looking at this line. If we plug in the x value, negative 4 over 1 squared would give me negative 4, and notice the slope is negative 4. If we go to this point here, and we plug in the x value, which is negative 4 squared would be negative 4 over 16, or negative 1/4. Notice the slope is negative 1/4. And if we plug in this point, which is on this line, and we do negative 4 over 8 squared, we get negative 4 over 64, which is negative 1/16. So depending on what point you are, that tangent line, the slope formula, the generic formula is negative 4 over x squared. And if you pick a point on the line and draw the tangent, it will give you that slope. So you're going to do the examples. Again, if you need help, come to the help session at noon and I will go through the 4 examples with you.